Good morning again, ladies and gentlemen. Good morning, all. We have the pleasure to have with us Professor Alvin Holder, and he is a former graduate of the University of West Indies, former student of Professor Tara Dasgupta. He is a professor in the Department of Chemistry and Biochemistry at Old Dominion University. He gained his PhD here on the UWI Mona campus in 1994. That seemed like it was a long time ago. We were graduate students together at some point in time, but of course he did inorganic chemistry. His research is in the area of biological and inorganic chemistry and bioorganic and inorganic reaction mechanisms. He's held several postdoctoral positions, and a part of the purpose of this is it's like a where are they now type of a series, because we want some of our graduate students to realize and see what options and possibilities exist for them as they transition through this period. And we know for many graduate students, you wonder, when is this going to end? But there's an end, and one has to be looking at what are you going to do after this period of time is over. So as I said, he's held several postdoc positions at Ohio State University, Virginia Polytechnic Institute and State University, as well as, interestingly, ExxonMobil Research and Engineering Company. I have never noted of a scenario like that, being a postdoc in a position of that nature. So I found that to be interesting. In terms of teaching, he's currently, of course, at Old Dominion University, and he has taught at the University of Southern Mississippi, as well as the University of Toledo in Ohio. He's had several graduate students and supervised several undergraduate projects as well. He's a recipient of several honors and awards. I mean, his CV is extensive, ladies and gentlemen. Has several research grants, including grants from the NIH and the NSF, and he is collaborating with many individuals, including many collaborators in the US. He has collaboration with South Korea, Canada, and collaborators in Trinidad, and also here in Jamaica. He has 86 publications, and I'm sure that they will continue to climb. And so without further ado, I just welcome Professor Alvin Holder to speak with us this morning.
Thank you, Dr. Gallimore. And thanks for everyone who are here. And if you don't mind, I will share my screen. Can everyone see my screen? Dr. Gallimore, can you see my screen? Hello? Dr. Gallimore, can you see my screen?
We're seeing your screen.
Okay, good. Thanks, Dr. Minot Kids. Hi. So it's good to be back, and I'll start. So first, I'd like to acknowledge you all and thank you all. And I would like to, let me go to get the laser pointer. So first, I'd like to thank the NIH for the MARC program, Old Dominion University for bringing me here from Southern Mississippi. And I'd like to thank the National Science Foundation for funding Army Corps of Engineers. And I'd like to thank Professor Peter Burnoff, Prof. Chris Plasukas, Professor John Cooper, Professor Bays, Professor Stephen Beebe, and our very own, my good collaborator, Professor Floyd Beckford, Dr. Jenny Williams, Professor Yat-Ching Sudin, and Reverend Professor Harry Gray. And these are my former students, current student, and you can see Dr. Carla Sue Marriott here, Dr. Michael Celestine, and we have some very good graduate students here as well. So we have our good logo where we say, when we do good chemistry, we do IRE chemistry. And I like to have the motto from the Lodge School, which I went to school in Barbados, Posant Quia Posse Videntor. And we have our good IRE Rastaman and such. So I'm going to give you an overview where I'm going to have the background and more anti-cancer studies and take some notes, but I'll try probably to go as fast as Usain Bolt, but I'll ensure that everything is finished in 50 minutes. So for many of the folks from around the world I'm originally from Barbados, and I moved to Jamaica in 1987 to pursue a degree in special chemistry as an undergrad. And to be honest, I would love to thank all of the teachers and who taught me in Barbados, my good lecturers at Cleavage campus who gave me the knowledge where I went to Jamaica at the University of West Indies Mona campus to really, really learn, should I say, tough and hard chemistry. So I like to give my big up to my good Taylorites, any Taylorites in the crowd. And I used to stay on Butchers, I used to stay in Attica. So here is when my students, my study abroad students from the University of Southern Mississippi. And you see this gentleman here, he obtained his PhD from University of Wisconsin-Madison in Wisconsin-Madison, Dr. Daniel Hinton. And I like to, this is a picture when the Butchers won the interblock sports. You can see the great Evan Allen, and this is me right here standing to the great Trinidadian, the man in four, and many of my former friends, but big up to the Taylorites. So I'm going to give you the inspiration behind my research. It all started at the University of West Indies. You can see here the ring road, and you can see the 4x1 relay team that won the gold in the London Olympic. And this is when Prince Harry beat Usain Bolt by the Mona Bowl. And one thing I love, my good Jamaican Aki. So I obtained my Bachelor of Science degree in special chemistry at the University of the West Indies Mona campus in 1989. And when I was in special chemistry, I would love to thank the late Professor Tara Dasgupta, Dr. Sadler, Professor Reese, Professor Pinnock, may he rest in peace, Professor Ellis, may he rest in peace, Professor Lancashire, and all of my former lecturers and my friends as well. I obtained my PhD in 1994, where I focused on cobalt and molybdenum, predominantly with kinetics. And thanks to Prof. Dasgupta, who allowed me to get my job started on January the 10th, 1994 at the University of West Indies in Cleavage campus. And I stayed there where I took 2 years of no paid leave in 2001. And the reason why I took 2 years of no paid leave, this was after Mommy had passed away in 1999, being the only surviving biological blood in my side of the family. She passed away in June 1999, my grandfather in December 1999. And I really wanted some more challenge. I went to the United States and I was a visiting assistant professor at the University of Toledo. Ironically, Professor Bedford was there. He allowed me to take his place, but that didn't last. It only lasted 1 year. Then I went to Virginia Tech as a postdoc, working with the late Karen Brewer, Professor Karen Brewer, to work on ruthenium, platinum, DNA, and cells. But the University of West Indies really is a great university, because before University of West Indies, I would have never have gotten the chance to learn new techniques by having a great foundation. And then I was a postdoc at the Ohio State University. That didn't go on quite well. I had a rotten mentor, I must say. Then I went to Colorado State to do a postdoc with the great Debbie Kranz to do vanadium chemistry, EPR spectroscopy, vanadium 51 NMR spectroscopy. And it was a postdoc there, but I wanted just to stay for 2 years. And then I went to University of Southern Mississippi. And although I would say Mississippi is a great place, to be honest, but at the University of Southern Mississippi, even though I had an NSF Prayer Award, funding from the Army, funding from the Royal Society of Chemistry, they didn't give me tenure. So you probably realize I move around, but one thing I must stress though, once you have good mentors, you can overcome all roadblocks. They didn't give me tenure here, but thanks to the Old Dominion University, who have been very supportive. They took me back in 2013, gave me accelerated tenure, which I got in 2017. And just July, I was promoted to full professor. So in reality, good things happen for those who wait. And I would say I'm humble for that. So you can see that this is just, part of what's taken from my curriculum vitae. Dr. Gallimore has told you all some good things about me. But one of the most important that really helped me was to get the NSF Career Award, thanks to my former postdoctoral fellows, graduate students, and undergrads at the University of Southern Mississippi. And I must really thank the University of West Indies for really shaping me up to teach me some good chemistry. I know you guys would have seen the honors and award where I was diversity champion. And OD has been really great to me. And one of the most important things was when Prof. Dasgupta told me, apply to become a fellow of the Royal Society of Chemistry. You have to be a member for quite a while. And that really helped me and such. These are some selected grants currently with Dr. Professor Sandeep Kumar, where we're trying to degrade microplastics. And just this year, being the role of a co-PI of a GRIs with $1.6 million in institutional support from ODU. And just prior to that was back in, just last year, I obtained a supplement to this MARC program, which I am the PI here as well. But I must stress that last year was a very good year where the COVID-19 forced me and my collaborators and our team to get funding. So the COVID-19 has its blessings and shortfalls, but it really forced me to stay at home and write. I must thank Professor Bays, where he's a PI, I'm the co-PI for an SF site, RU site for community college students. But the most important is the NSF Career Award. Here are some of my publications, and one of them that sticks out is one with our good Professor Conrad Ingram, where we have collaborated, and a former postdoctoral fellow who was a grad student with the Professor Richard Fearman, one of my colleagues in special chemistry, and Varma was in my lab. Conrad smiled and said that this paper that got accepted was his ticket to give a conference in Russia. Thanks to Dr. Mark Lawrence, who is a lecturer at University of West Indies. He was a postdoc in my lab, and we have had a lot of publications. And just recently, there's one with Chloe, Lindsay, Dua, Faye, Yara, who's in the crowd, and my collaborator, Dr. Stephen Beebe. We have this paper that just got accepted. And there's one that I published as part of the MARC program, which has some really good mentoring, the way how Prof. Dasgupta did it. I will thank Dr. Sadler McKnight for giving me insight where we've really published this paper. We produced a special volume on Inorganic chemistry for Prof. Dasgupta. And here, there's another one with, you can see Mark has really done a really good job with Dr. Michael Celestine as well, and publication of such. This is a cover page of the work with Conrad, the great Conrad, my mentor. He was a grad student, I was an undergrad, and he's one that grew me. If I do get $10 million in research money, Conrad would get $100 million. So he's always 10 times more richer than me. So these are some chapters in textbook. We love to have the students going to lunch. We take them to lunch. And this textbook, and where Mark is a co-editor, this is a textbook in honor of my former postdoctoral fellow, Professor Karen Brewer. We have some textbooks on ruthenium as such. So we've been very prolific in such by having Mark as a great postdoctoral fellow. So this is Dr. Michael Celestine. He obtained his PhD in December 2020. He's from the US Virgin Islands, and Raj from Nepal. He got obtained the same time as Michael his PhD in 2020. This is Elizabeth. She's in her 4th year as a grad student in my group, and she's half Jamaican. Jasmine was a MARC student. She's now starting her 1st year as a grad student at Bronx University. Jade was in the MARC program. She came to have lunch with us. She's a 1st year grad student at Virginia Commonwealth University. Jennifer Mejia, she's a 3rd year grad student here at Old Dominion University. So my research is based on transition metal chemistry, medicinal applications, anti-cancer, anti-diabetic. We also do industrial applications. And one of the most important that we trying to do is sequester carbon dioxide and produce hydrogen. And more important is their biodegradable polymers, degradation of polymers. So we have developed plenty of materials at University of Southern Mississippi, We've done a lot of cell work, anti-diabetic studies, artificial photosynthesis. And most of my students have gone on to do great things. Dr. Leslie Allen, she was a postdoc in my lab. Jennifer Vital, she's originally from Guadalajara in Mexico. She's a medical doctor by profession. There's Dorothy, she works with the DEA. She's a forensic scientist. All of these students are part and postdoctoral fellows part of my lab. Grad students, I have grad students from Barbados and Jamaica. Sophia being the first, Gabriel the second, Ross being a Mass MPhil student, Vince, another PhD student. And at Southern Miss, I had Lamariet and Nerissa. Nerissa used to work with Dr. Richard Fairman. She's now, after obtaining her PhD at Louisiana State University, she's now an assistant professor at Walla Walla University in Washington. Then now we have at University of Old Dominion University, you can click here, but I'm not going to click here. Jimmy obtained his master's with me. Michael in 2020, as I mentioned, and Raj. And these are here, Elizabeth, Crizel, and Dua. Dua is from Saudi Arabia, and Crizel is originally from Guam. And this is a slide where I usually utilize to advertise my research. You can see here of insulin-like vanadium, anti-cancer for photocatalysis, metallomesogens, various NMR, nuclei, collaboration. We also show some gels. We also look at EPR, vanadium-51 NMR. And one of the most important things that we do is that we grow single crystals for X-ray crystallography, and we do make supramolecular molecules. We have equipment. And by the way, Dr. Gallimore, I'm looking to see if we can get 2 students to come from UWI to pursue the PhD degree with me in fall of 2020. We have loads of equipment in my lab worth more than $300,000 that were given to me as a startup package from Old Dominion University. So being a proud monarch, being a proud UE graduate, being a proud Taylorite, I'm very happy that God has been good to me. Now, if you look at projected deaths from 2005 to 2030, you'll notice that cancer is ever going up in terms of study in rates. But one of the most important things that I would say that's very stressful is mass shooting in the United States. That is something that is, just as bad as cancer. But if you look here, 10 causes of diseases, cancer ranks as one of them as such. Not only have suicides and accidents and pneumonia and influenza as such, but cancer is a problem. So if you look at cancer in terms of races between 2001 and 2005, you'll notice that African Americans have the highest rates of cancer when compared to Asian Pacific Islanders. But if you look at Asians and Pacific Islanders, one of the most important that really help reduce the rates of cancer is utilization of one natural product, which I'll tell you in a second. But look at Barbados now. In Barbados, it's been predicted that there will be 1,657 new cancer cases in the year 2035 and 858 cancer-related deaths in Barbados. You can see the cancer-related mortality in Barbados is increasing with time. We are here, and that is really not good for Barbados. Now, why I'm focused on cancer is that Professor Jeff Sykes, thanks to Prof. Das Gupta, who allowed me to get a Leavenworth Fellowship to do research in Prof. Sykes in 1995, and nearly every summer. Professor Sykes used to be a full professor at the University of Newcastle upon time, now called Newcastle University. Newcastle is here, you can see north of London, and is near to Scotland. It has the Hadrian's Wall, which the Romans built from the west coast to east coast of Newcastle. It has the Newcastle Bridge and it has the Tyne Bridge. And here you can see the Millennium Arch. So on this side is Newcastle by the quayside. And on this side, on my right here, is Gateshead. I love that city. And then we have Dr. Edward Stiefel, who I spent a year with him, 1996 to 1997, at Exxon Research Engineering Company. Unfortunately, Jeff passed away with prostate cancer. Ed passed away with pancreatic cancer. The same month I arrived at Southern Mississippi, Professor Harry Gray called me and told me that Ed had 2 weeks to live. Unfortunately, Ed was misdiagnosed for an entire year with pancreatic cancer. They've been very helpful with me, where I work with both Ed and Jeff, on molybdenum. Unfortunately, my former chemistry teacher, Mr. O'Shea, he passed away with colorectal cancer. We have Professor Seitz mentioned with cancer and Ed. My good two high school friends, Errol and George. Errol had cancer of the face. George had colorectal cancer, but fought it. Mr. David Thompson, my former prime minister in Barbados, he had pancreatic cancer. Professor Malcolm Chisholm, as you know, he was the external examiner for UWI. He passed away with colorectal cancer. So more important is my chemistry teacher, this is Mr. Shea, this is Mr. Thompson, this is Errol, this is George, my high school friends, this is Malcolm, this is Jeff, and this is Ed, and this is Mr. Shea. So these are the pillars who really helped me in terms of chemistry, and my good friends in sports as well. You remember back in 2020, August last year, the Black Panther, Chadwick Boseman, he died of pancreatic cancer. So cancer, reality, is a big problem. I went to this conference on the 12th annual Conference on Health Disparities conference in University of North Texas Health Science Center in Fort Worth in 2017. Bear in mind, you're going to find that these slides are going to be very gross, but it has a health disparity among African-American women who are African descendant, namely triple negative breast cancer. So this is a case study where the patient, her partner, noticed this form of cancer for many, many, many years. I didn't tell her. The cancer spread and she had a mastectomy, and is known that she had to use carboplatin, Taxol, and Herceptin to help, put the cancer and make it relapse. And this is just a case study. When I went to spend a summer at York with my good mentor and good friend, Professor Duncan Bruce, I gave a seminar on Monday, July the 10th in 2017. And Joe, his administrative assistant, told me that she had breast cancer. She had a double mastectomy. She had hair loss, she told me, but you can see Joe here smiling that Monday, and she took a photo with me. Now, just to show some close friends are fighting cancer. So this is what I usually tell my friends. I tell my friends this. Friends don't let friends fight cancer alone. Remember that. Friends don't let cancer fight cancer alone. So I would like you all to remember that. So I'm going to go back to the slides because the laser pointer. So the treatments of cancer: chemotherapy, radiation therapy, surgery, hormonal therapy, aromatherapy, and people use Taxol and natural products. Cisplatin, which contains a metal. And cisplatin has been used for a number of years, but there are many undesirable side effects, where the patient will lose their hair, beta cells are killed, nausea, and so forth. So the main thing is this. People are using turmeric. Turmeric is very good, as you know, curcumin and fighting, COVID-19. Is used by the actresses in Bollywood to skin toning. Turmeric is really good. Curry is very important in Jamaica, all around the world. Even it's used to fight Alzheimer's disease, Parkinson's disease, and many forms of diseases as such, including multiple sclerosis, asthma, arthritis, bronchitis, you name it. Now, why elements? We know that vanadium, you'll hear more about vanadium and chromium. Well, these two elements in most compounds are used to fight diabetes. Boron is used in growth. Even you'll find out why arsenic is very important in some forms of tin, lithium for manic depressive. Well, believe it or not, this arsenic compound here, Henry VIII used, guess what? arsenic to treat his syphilis. The Chinese have used copper to sterilize water. Some people, Hippocrates, use mercury, and there's so many forms of even gold to fight in many forms of disease, including tuberculosis as such. We're looking for alternatives to platinum-based complexes, including those containing rhodium-3, titanium, metvan, this is vanadium-4, chromium-3 for, nitrite-containing compounds where they're good vasodilators, even those derivatives of ferrocene to fight in malaria and gold to fight in cancer. Vanadium, many people don't really realize can be utilized to fight cancer. Vanadium, named after Vanus, the old Norse name for the Scandinavian goddess Freya. Vanadium has many various oxidation states, +5, +4, +3, and +2. And believe it or not, I just completed a lab course just now, and the students made these various oxidation states of vanadium. Vanadium has been reported as way back as 1899 vanadium-containing species, vanadium-5 as such, can be utilized as anti-diabetic in nature, insulin-like in nature. But it's only now that many people are utilizing vanadium to fight cancer, but vanadium is very good for you, that even in Japan, this usually sell vanadium. And why I'm focused on vanadium is that Barbados is known as the amputation capital of the world. My first cousin died on the morning, December the 2nd, when he came out from the Caribbean Academy Science meeting. She had a rotten foot, but she claimed she wasn't diabetic. But I was wondering why, when it was in Barbados, why so many people used to be amputated. Now younger people are getting amputated in Barbados, including some friends that were at school with me. We grow a lot of sugar cane. And to be honest, if I had continued long enough, I probably would have been amputated by now. Vanadium, of course, Chris Orvik, he produced something called BMOV. And Debbie Kranz synthesized many vanadium compounds like vanadium-5, oxidation +5, oxidation state +4, +5, to really fight diabetes. This is BMOV. Maltol is a food additive. It smells like a freshly baked bread. Vanadel acac, vanadel sulfate, vanadium chromium, all of these are utilized to fight diabetes. They're very good in taking someone from a hyperglycemic state to a non-glycemic state, and they do act like insulin. This is a review that Debbie Kranz and our good friend Jason have written. There's just maltol, and even bodybuilding supplements has in BMOV, believe it or not, and people trying to look ripped and to look lean as such. Streptozotocin is utilized to make, when they actually carry out in vivo studies, they restore rats, make them type 1 diabetic as well, but in large doses, and type 2 diabetes in low doses. And you can see this is a nitrosamine. Even though it's a nitrosamine, is a carcinogen, they utilize this to really kill the beta cells in order to make the rats diabetic as such. This is just some features using BMOV, which in essence work just as efficient as vanadel sulfate. Just came from Chris Orvik from the University of British Columbia. This reached phase 2 of clinical trials, but he did not have enough money to raise it for phase 3 of clinical trials. And we do know that Varma has made a good compound that he's utilizing to fight diabetes. And this is Varma Rambaran, who was in my lab as a postdoc. If you didn't know, but I know Winklet knows that vanadium can be uptake by Acidium nigra tunicates, like most heavy metals. These are indicators of heavy metals where they usually thrive in heavy metal polluted water. Crude oil from Venezuela has a very high content of vanadium. And a mushroom, the Armenian muscaris mushroom, which Professor Lancashire taught us about this mushroom in Jamaican special chemistry, and I was really hooked on vanadium. This is the crystal structure of amavadin, which comes from this mushroom, which is very hallucinogenated as such and grows in the pine belt of Mississippi. These are some forms of tunicates, but the main one is this black one. And I don't know if Dr. Gallimore, this is you when we met to Port Royal. And this is Brian, and this is Jenna Garcia, who is a graduate at Texas A&M University. And Jenna was so excited to found a tunicate when we were in Port Royal. So this has been Dr. Gallimore, and her grad students were looking for sponges for her research when I took the students back in 2018. And if you didn't know, but not in the big areas live in the same mushroom. I remember I've read this book as a little kid growing up. Cobalt. Cobalt is a very important in DR, where Apple is mining all of the cobalt to make the iPhones. People say cobalt is very abundant, but I wouldn't really say that because it's 0.003% on the Earth's crust. Cobalt, believe it or not, crystal structure from vitamin B12. Dorothy Hodgkin, she got the Nobel Prize in in chemistry for solving the structure of vitamin B12, and also this is its structure as such. And she also proved that it is a mono ion current with a cobalt-3 metal center. We do know cobalt is found in very low percentage in the human body, just like all of the essential elements, including some titanium. We do need from potassium, some boron, nickel, iodine, selenium, manganese, you name it as such. Vitamin B12, the little pink dots, I did utilize it too as well. It's very important for if you're, need a lot of energy and you can purchase it as such. Cobalt is used like in this cobalt-3 shift base to fight herpes simplex virus 1 and utilizing it called doxivir as such. We're interested, like most of us, where we've done some work similar to utilizing something called thermosemicarbazone complexes. And this is first reported in as a phase 2 of clinical trials. It has the thione. It can coordinate, in this case, through the amine through this nitrogen, or in this case, it's a tridentate here as well. And this is some work that me and Professor Floyd Bedford published back in 2009 as some good collaborators too, where it shows that we grad students at Mona campus can collaborate. This is Leslie as a co-author. Remember Leslie? She's Leslie Lewis Allen. She was a postdoc in my lab. And Navendra Siram, who is the departmental chair, University of Rhode Island, I think Department of Chemistry, just to show that we have collaborated and we are good friends. We're interested in fighting triple negative breast cancer, utilizing some cobalt-3 complexes. And this formed the thesis, or Jimmy's thesis, with my good collaborator, Dr. Stephen Beebe, who is an expert in nanoseconds pulse electric field to really, really sensitize cancer cells. This is his setup, and giving some great pulse. And Dr. Beebe is a pioneer. He's one of my greatest collaborator here at Old Dominion University. So if you look at here, this is a control. So this control here is where no pulse, in essence, with this xenograft cancer here. So imagine you're measuring the volume of the tumor with respect to days as such. So at day 11, here, you hit it with 300 pulses. You can see the tumor is really decreased in size. As such, remember this is a control here, this 300 pulse, 1,000, the volume of the cancer really has diminished as such. So we decided now to, based on our work, I must stress to Jasmine. Remember Jasmine is now a first-year graduate at Brown University. This is the work that we published with Dr. Stephen Beebe, where this compound was made by an undergrad of mine back in South Mississippi, Jessica Arca, originally from the Philippines, and several undergrads who really involved my collaborators, including Yuck Ching, William Jarrett, and Crizel's here as well, Floyd again. And this work was funded by the Army, Dr. Kropek, and undergrads who were in my lab, and of course, Michael. So this came out a year ago. So in essence, when we look at cell viability of this thermosemicarbazone complex that we made of cobalt-3, this has an IC50 value where 50% of the cells are alive and dead, with IC50 value of 34 plus or minus 3.5 micromolar. We compared this is, remember, cell assay, MTT assay, with using 41 metastatic breast cancer model and a xenogenic xenograft mouse base as such. We look at the ligand, IC50 value is 50 micromolar. We look at the precursor diacryl complex, the cobalt 3, and this had an IC50 value of greater than 100 micromolar. And cisplatin is really not as effective as cisplatin, which had 3.75 plus or minus 1.08 micromolar. But in essence, it's still cytotoxic to the cancer cells. We also carried out binding studies using spectrophotometric titration with the ligand and calf-thymus DNA. This is the ligand here as such. We also looked at the interaction of the complex and compared it with ethylene bromide and this DPPZ complex, which Dr. Barton has worked with. And we were able to obtain a binding constant 8.1 by 10 to the 5 for the ligand per molar and 1.6 by 10 to the 4 per molar for the complex as such. Ouch. So in essence, you can see, in essence, we still have fairly good binding as such. So we were fortunate with Dr. Sedin of Florida International University, UWI, where we were able to show that the complex can inhibit human topoisomerase as such. So this is showing how you can go from a supercoil to relax as you vary the concentration as such, including when you increase. Can someone please mute your, please? And Dr. Beebe and his crew and Jimmy carried this work by using the role of caspase cleavage on cell death, where we add ZVAD, FMK, minus ZAD, MFK. And what he found is that this more shows that this is a cell permeate pan-caspase inhibitor of apoptosis. And we were able to compare the IC50 value, remember, plus or minus, and to show that it has some caspase activity. Then we had effects of the mitochondrial membrane potential, and you can see it changes with respect to concentration going from 0 micromolar through to 80 micromolar. And this really caused it to be really dissipated in the 41 LUC cells as such. We found that the compound also induced autophagy, where it seems that as we fed the compound to the cells in essence think them as more like a foreign body and try to protect themselves as such. So we see we go from 5 micromolar to 80. You can see that in essence there's actually some you can see in terms of flow cytometry, there's actually some gradual change in terms of the fluorescence as such. Then we have proof that there's inhibition of autophagy with necrostatin 1. This is plus with it or without, going from, you can see from 22.8 micromolar to 32.2 micromolar IC50 value. And it says that this does not even have a great impact on the necroptosis as such, but in a sense, it can still do something. But more important is this: we try to have pulse it by having a synergistic effect with the compound, with and without the complex as such. And the results were all over the place. But more important is this, as this dual treatment synergistic effect, is that we're yet to really look and see what's happening. But I do believe that the nanopositive electric field is reducing the cobalt 3 to form labeled cobalt 2, and that cobalt 2 being labeled that in essence that the ligand may not be coordinated to the metal center, hence reducing its efficacy as such, but that's yet to be carried out. So if you look at this now, another form of cancer, which is called melanoma, even us with a dark skin complexion can get melanoma as such. People are using PDT, photodynamic therapy, to fight cancer, where you activate a drug with light at the tumor site. This is a porphyrin here as such. 5-aminolevulinic acid is a precursor to these type of porphyrins. And what 5-aminolevulinic acid, this is its 98%, greater than 98% purity, is that it seeks and finds the cancer, and it makes the photosensitizer, which is a porphyrin. You excite it with light and you fight the cancer. what really happens is that the porphyrin absorbs light, becomes activated, and transfers its energy from triplet oxygen to single oxygen, which is reactive oxygen species. And what it does, it destroys the cancer. This is a good review, New Light on Medicine, Scientific American 2003, which really has some really good pictures that tells you a lot about photodynamic therapy. Photodynamic therapy is used to fight cancers and also non-cancer related, age-related macular degeneration. I'll tell you more about that. This is a review, but unfortunately, the review is written in all black and white and no color photos whatsoever. It's an excellent review, to be honest. So I must give a big up to my students. We just got this paper accepted, and not really accepted, but is online, yet to be designated, the page range as such. First author is Chloe here. Second author is Lindsay. And these are two undergrads who are trying research in my lab. And also, we also have Khadija, Yara from the Palestine. And Yara, I would like to thank you. You're here in the audience. You're the one that made this come to reality. And Dua from Saudi Arabia. And my good collaborator, Dr. Stephen Bibi. So just to show you how undergrads and grad students, and predominantly have an undergrad, Chloe wants to be a full professor, and how undergrads can become first and second author. But remember, they all decided as such. I'm proud of my students as such. And one thing though is that my lab is predominantly 100% female grad students and more than 90% female undergrads as such, is that we need some more grad students from the Caribbean to really help complement who we have in the lab. PDT can fight this ear, nose, and throat type of cancer before 24 hours. This is a tetrahydroxyphenyl chlorine, 7 days and 4 months. And one of my former undergrads used to tell me, Dr. Holder, this is a smoker. So you just see it's really good. It's used to fight age-related macular degeneration, where the macula, which is the retina, can be proliferated with blood vessels. And when this is actually proliferated blood vessels, this person has this type of vision. But as soon as you use vitreporphyrin, you can just destroy those blood vessels and have normal vision 20/20. So just show you PDT can be utilized as that. It's less invasive than surgery, can be targeted precisely. But one thing though I must mention as well, it has less scarring, but there's some side effects in PDT. It makes the patient very sensitive and causing to fluoresce. So the patient have to be living like Dracula. So we have vanadium, other metals that can intercalate with DNA and fighting cancer. But I'd like to tell you something about what we can do. And these are just some abbreviations. We published this work in 2013 with my good collaborators. And I'll tell you some more. When this work came out in 2007 by Sasmel and co-workers, by using some shift bases to coordinate, shift bases that contain, guess what? L-tryptophan. L-tryptophan, we know, is a good and found in turkey breast. L-tryptophan can be used as a PDT agent. We have these bidentate ligands, 110 phenanthroline, DPQ, DPPZ, but as you increase the aromaticity, you increase the selectivity to photocleave DNA. Even L-methionine, which of course is a sulfur-containing amino acid and shift base as such. We made some more of the, we made this as a hydrate because we weren't able to reproduce making this compound, but we modified it with the great undergrads I had in southern Mississippi. And we made 2 complexes. They're both binuclear, one containing ruthenium-2, vanadium-4 with bridging ligands. You can see this is the bridging ligand container DTT moiety. I must stress, when I was working as a postdoc at Virginia Tech, Karen Brewer told me, don't try to reproduce her work or do anything with ruthenium. Colorado State, Debbie Kranz told me, don't do anything with vanadium. So I decided to make one compound containing both species, metal centers. Because remember, when I was in Prof. Dasgupta lab, I worked with Cobalt 3, molybdenum 6. So I had the upbringing of liking binuclear complexes, polynuclear complexes, incomplete and complete cuboidal clusters with Ed Stiefel and Jeff, respectively. We decided to use the chloride salt of this against melanoma cancer cells, human fibroblast cells, which are non-cancerous, and we decided to use a wavelength of 740. Why 740 nanometers? Well, this is what the LED looks like, or the red light. When people are carrying out PDT, the therapeutic width is usually between 630 to 650. Why? Because the longer the wavelength of the light, the more penetrated they are in deep tissues to reach the cancer. Imagine we're using 740, so this would probably reach like 5 centimeters or more below the epidermis. This is the light toxicity with compound 3. The upper panel is non-cancerous HFF, melanoma below. And this is the light. And you can see around 5 micromolar, 20 micromolar, you can see clearly the cancer cells are dead. Compound 4 essentially has the same type of efficacy. Jenny Williams, my good collaborator at Stony Brook, she utilized, remember, H2 is, we use a compound that is a phthalocyanine, be it against the melanoma. It wasn't toxic when compared to cisplatin, the control, human fibroblasts, non-cancerous. The compound that contains mononuclear vanadium, you can see in essence, IC50 value plus within the same range as cisplatin, is toxic to some extent to human fibroblasts, but compounds 3 and 4 are more selective towards melanoma cancer, and these compounds are not toxic at all to the non-cancerous cells. And this is dark toxicity. So you saw in essence what happened in the light. In the light, they had tremendous efficacy. So our compounds can be utilized when we modify them even more to carry out some selective and using drug deliveries as such, is that these can be utilized in fighting cancer. So these in essence are just of the conclusions that we have compounds that are able to have synergistic effects. And my advice for you all is that I really like to advise the ladies to do your mammograms, the men to do their PSA tests, and don't forget to, women and men need to do colonoscopy. When I was in my 20s, my former PE teacher saw me in Bridgetown, Barbados and said, listen, don't wait until you're 50 to do a colonoscopy. I was fortunate that after doing a colonoscopy years later, I still don't have any polyps. Use other cancer detection techniques, diet, exercise. And one thing, remember the WHO has mentioned too in 2015, that processed foods that contains a lot of nitrites and nitrates do cause cancer. Have no stress. To be honest, I know United States is always a stressful country where you work. We know we got a lot of Zoom meetings and emails, but try to be relaxed. I know I was in Jamaica, oh my goodness, and the knockdown and the curfew had everything. But more important is clean water, workforce safety, and environment, and follow the rules and use common sense of COVID-19. If you haven't taken your vaccine, please do. Why say that? A good friend of mine, Adrian Stanton, forensic nurse in London, he had COVID-19 last year. He was afraid to go to the hospital. This is what Stanton used. You know, orange juice, honey, broadleaf thyme, garlic, and everything he could throw at it. And he blended everything. And to be honest, even turmeric, busy, and you'll see that in white, even the custard apple. I know some people use what Bob Marley used, and this is a photo taken with Marisa when we were at the Bob Marley Museum. But guess what? The fever grass, the busy, guinea hen weed, vervain, and what Dr. Sonia Peter and her Biocultural Education and Research Program, everything can be utilized to fight the COVID-19. My mother-in-law had it. She refused to take the vaccine, and Dr. Sadler McKnight will tell you, we were talking about that. She used all of this and she fought COVID-19. I gave it to my cousins. I gave it to a lot of my students as well, and people who utilize it, and the herbs do work. Not to say that you can only rely on herbs, but more important is that once you build up your immune system with a lot of vitamin C and zinc, you can fight COVID-19. And my cousin fought it. My grandfather's nephew, he had dementia, and he didn't at that time, if they had told me that he had COVID-19, he would have been still alive. And I would like to thank Prof. Das Gupta and crew, and see Prof. Lancashire Shruva, and the great rum master blender Joyce, Joyce Spence as such, John Bohr, his wife, maybe met the Academy of Science meeting. And Prof, I really owe you a lot. And Prof, I know I'm going to see you sometime soon. We're going to see you again. And this is what I have in his honor. I'd like to thank my former high school organic chemistry teacher. I was in sixth form where I got an A at A levels. Colin Harper, Prof. This is Professor Karen Brewer. And this is when we sat on the table. You can see my good friends, and may he rest in peace, Professor Pinnock. You see Paul, Kamal. This is Professor Sean McDowell. This is Professor Roy right here. This is Professor Sikazi in Tingwa, and Prof looking at us. And my good friend Harlan that gave me, and Professor Basha. And you can see Rosalba and Pat. Harlan gave me some seed money to do cancer research. I'd like to thank you all. And this is when I was in sixth form, my friends and my former French teacher and Mrs. Moore, the secretary at high school, the large school, and Mrs. Moore still, all my teachers still look the same. My friends, and one thing that I love doing, I love planning and having moonlight picnics. I love planning. I'd like to thank you all. And that's it for now.
Thank you so much, Dr. Professor Holder. That was a really, really great talk, and we really appreciate all of the things you wove into that talk today. I am going to ask one question, but hand over to my co-host, Mr. Denny, to continue with the questions. One of the things that you said in terms of funding, you spoke about the Army. What role did the Army play? What exactly would the Army have funded in terms of your research? And why would they want to have funded your research?
Well, I don't know if you know, but when the soldiers go out, you see them carrying this big backpack on their shoulders. That's for them to get energy. So they would like to make a system where you can split water to make oxygen and take the protons and make hydrogen and use hydrogen as a fuel. Small little system. So in 2010, okay, in 2009, in 2008, I got a migraine card, and I was only able to go to government labs like Brookhaven Argonne National Lab in 2009. And in 2010, the Army wanted Brookhaven National Lab to give them some help in making hydrogen. Okay. At that time, that was during the summer, there was a book company that wanted me to write questions for them for $100. I was invited, and I said, you know what? Let me go to the meeting with the Army because you never know. So the first year, 2010 to 2011, they bought all supplies. 2011 to 2012, they gave me $33,000. And from 2012, they gave me $810,000 and sent me to England. And guess what? Because I proved to them that I can make hydrogen, and they gave me some good funding that helped me get $500,000 in NSF Career Awards. So the main interest was to make hydrogen as a fuel, so you don't have to rely on fossil fuels. And also, you know, soldiers like us get cancer, so they also put that money help to make anti-cancer compound. Because you know, soldiers do get Alzheimer's, they're the same human beings like us too.
Yeah, okay. Thank you so much. Thank you so much.
Any questions, Val?
Are there any other questions? I'm handing over to Marcel.
Okay, Doctor.
You have a tobacco class, yes.
Okay, so thank you, Dr. Gallimore. Are there any other questions for Professor Holder?
Thanks, Mark. I see Mark in the crowd. Professor Reese, Micah, Zoe.
Go ahead and unmute your mic if you have any questions.
Do you know that Miss Zoe Amy, her father went to school with me? He's in the photo you guys saw. I don't know if you guys saw that. Hi, Zoe. I guess everyone is quiet.
It appears so. Professor, hold on. And one of these slides you were speaking about using herbs
Yes,
to help alleviate some of the treatment, some of the ailments with the COVID-19 thing. Like what did you exactly? You didn't really say much on it. I was curious about like what herbs it kind of help alleviate some of the symptoms.
Well, not only alleviate the symptoms, but she was supposed to come back with us at the end of August. So because she was tested positive with the antigen test, she claimed it was just a cough. So the PCR sure was positive. And we said, look, you don't want to take the vaccine. Take these herbs, steam. I know Jamaica using steam with menthol, because you don't know if you know, but if you use menthol and you breathe in that hot vapor, that can help kill the virus in your nostrils. So by giving her those herbs, she went on the herbs for 2 weeks. And guess what? She fought the COVID-19. She's up here. She came on the 3rd of this month, and the COVID-19 is gone. My cousin utilized it. A student I was virtual mentoring, she used it. A student used it for her father. One of my students, practically he used it. He had COVID-19 last year. He went to the West Indian groceries and bought guinea hen weed and the same fever grass, and also busy. And these students and people I know utilize the herbs with honey and everything, mix everything together and fought it, to be honest. And even some people who refuse to take the vaccine have been utilizing it as such as well. But it does work, by the way. Much better than horse dewormer, as Professor Lankers said. You don't want to take the things that they give to the horse. Don't do that. I agree, Professor Lancashire.
Okay. So it's something to kind of help to alleviate a lot of the ailments to kind of push through, and you can take the vaccine through.
Yeah, but don't forget to take the turmeric, because my cousin told me that before I told her about the herb, she told me when she took the turmeric, her congestion, her chest was relieved. She didn't go to the hospital at all. But when she used the herbs, everything came back. But one thing though, one side effect that she had a bulging disc. That, because if she had spoken to me much earlier, that side effect would have been so disastrous. But she's fine now, as such, and she's still alive. She and her mother, they're still alive. But her father didn't contact me in time. She was panicking.
So would like to thank you on behalf of the Department of Chemistry for coming and giving such an interesting talk. I know the various applications of these vanadium compounds I found that to be very interesting. And we thank you all for coming out as well. And we look forward to further collaborations with you, sir, and the department. And I wish you guys a safe week, and I'll see you next week for the next week of seminars. All right, enjoy the week.
And thanks for the invitation. And remember to send us the link, because some students who weren't able to make it would like to see the recording. Thanks, Professor Lancashire. Thanks for the book with Professor Layla. Great book. It's good to buy the books and give back to the chemistry department. Every time I come to Jamaica, I usually buy the books all the time from Professor Lancashire. Please, all the UWI alumni, please do it, support and give scholarship to the students who need this scholarship right now.
Very well. Thank you.
Bye now.
Okay. Thanks, sir. Enjoy.
Bye.
Thanks, everyone.
Good.
Okay, bye. Okay, thanks
you.
again. Thanks, Winklet. Thanks, everyone. Okay, bye. Thanks, Terry. And okay, bye. Huh?